looking at these scatter plots of real data, what's the pattern that they follow? And we have to remember some of our parent graphs. So out of those 4 options, can anyone tell me what one of them is? Do we see any linear? What do you think, Anthony? 2 looks to be linear. I agree. Because if you were to draw a best fit line to kind of model that data, that is a line. And on 4 as well, I think that also looks linear. How about quadratics? Do you see any quadratics there? Anything that looks like a parabola? Maybe. We don't really have enough on 3. If this were to be a parabola, we would need some indication that it was going to turn back around and go up. So I'm going to say no, and actually the same would be true for 1. I would need some indication that that's going to come back down, and right now it doesn't really look it. So I'm going to base it just on the pattern that I see. This pattern kind of looks like this. What is that? Exponential, very good. And how about this one? This one's we're a little rougher around the edges with this type of function. Anybody? No, rationals would be, let's add a rational. Not a bad guess. Rationals tend to be in 2 parts. Rationals is going to be a weird one because you would almost need 4 quadrants, and rationals would do something like this. Remember, they're kind of split into 2 parts with asymptotes. So this one would be rational. I got to be honest, I don't see any data ever in real life. Well, not that that's not true. I've never seen a rational scatter plot. Not that it can't happen. It could. I'll give you a hint for this one. It's the inverse of this one. What's the inverse type of function to an exponential? Come on. What do you do when you're solving an equation to undo an exponent? Log, Scott. When the variable's in the exponent, we want to get it out. This is a log graph. Okay. How about, what if I did something like this? I'm going to add a 6th one here. What if I did something like this? What would you think about that one? Sine. Very good. Do you see it? The sine graph is kind of starting on the midline. That would be a sine. Okay. And similarly, if I did this, well, that would be cosine. Because this one's starting at a minimum. Good? Alright, so once we see a scatter plot, we have to make a decision. Now, we're going to use our calculators to create scatter plots. So here we're given a bunch of different years. Now, it says that the population of Jamestown has been recorded for selected years since 2000. So how many years since 2000 is this? 2. and this is 4, and this is 5, 7, and 9. Those are really going to be your x-coordinates. And then there's the population. And we need to break out our calculators and create a scatter plot. So, what to do, what to push to get this all to come up. First of all, we have to turn our scatter plot on. So up above the y equals it says stat plot in blue. So hit the second button and then y equals. And all of your plots are probably off right now. Go into your first plot, turn it on. And there's a bunch of different types of plots that your calculator is capable of. A scatter plot, a linear kind of graph, a bar graph, a box and whisker plot. Okay? We want the scatter plot, which is already highlighted. We're going to insert our x-coordinate into list 1, and we're going to insert our y-coordinates into list 2, so we're all good. Now we're going to enter data the way we did before. So hit your stat button, which is down here, right under your delete key. There's a stat key. Jacob Phillips, are you doing all this? Edit your list. If there's stuff in there, scroll up, clear it all out. Scroll back down, it should disappear. Clear it all out. Okay. So our x-coordinates, our years, are 2, 4, 5, 7, and 9. And our populations that run along with that are 5564, 6121, 6300, 6812, and 7422. Okay, so our steps here were to turn on the scatter plot, which came from second stat plot. And then we input data, and we get, what do we do for that stat? Edit. And now we're ready to graph it. I'm just going to hit graph, and what do I see? Nothing, right? Well, first of all, actually look at, I do see something that you probably don't see. Do you guys see that? Yeah, that's because if you guys see something else, just hit your y equals button. That's because I have a previous equation in there. I need to clear that out. So when I hit graph, I should just see my scatter plot, and of course I'm seeing nothing. Because my window right now, my x-coordinates are going from -10 to 10, which is fine. But my y-coordinates are going from -10 to 10, and no wonder I don't see anything. Because my y-coordinates are gigantic. Okay? So when you need to now graph your scatter plot and take a peek at it, set your window. Your x-axis, ours can go from 0 to 10, and we can count by 1. But our y-axis, we can go from 0 still, but what's our maximum population? 7422, so I want to go at least above that. I'll go from 0 to 8,000. And now when I graph, I should see something much better. Okay? Now, what does that look like to you at first glance? Linear, I would agree. The only thing I'm a little skeptical of is all of my graphs are really jam-packed in the top. All of my points are jam-packed in the top. Maybe my y, just to get a better feel for the trend, maybe my y-axis only should have gone from like a little bit below here, so from 5,000 up until 8,000. I wonder if changing my window is going to give me a different feel, or do you think that still looks linear? What do you think? Did that change it, or do you still think it's linear? I agree. But sometimes getting closer might pull out a different pattern, and there's really two different possibilities. But I would agree both of these are linear, and so we are going to write an equation for the best fit correlation. So we're going to write an equation for the linear function, and your calculator is going to do that for you. Let me just add here that we had to set our window appropriately to the data. And here's where I'm going to run the correlation. If I hit Stat, scroll over to Calc, and we have so many types of regressions. We have a linear regression that we will use for lines. We have a quadratic regression that we will use for quadratic or parabola-looking scatter plots. Cubic and quartic we're probably not going to use often. Those would be our higher degree polynomials. So a cubic one, just look up here quickly. A cubic one would look something like this. A quartic with a degree of 4 would look something like this. Kind of that would put us in our polynomial chapters. I'd be surprised if they did something like that. If we scroll down, there's a second option for a linear one, which they're pretty much the same thing. It's just in this one, when they give you A is your slope, and this one, when they give you your B is your slope. I'm not really positive what the reasoning is for two of those. There's the ln regression. That's your log. Okay? That's your log regression. Exponential regression. Power we're not going to do. Logistics. Sine regression. That's our trig. There is no cosine regression. Okay? Because, truthfully, even if something's a cosine curve, it can be written as a sine curve for reasons we didn't fully get into. But this only runs a sine regression. And that's it. So we want to select option 4, which is linear regression. Our x-coordinates were in list 1. Our y-coordinates were in list 2. So we're just going to calculate. And our format is y equals ax plus b. Our a value is approximately, we'll go to the nearest whole number, 261. So y equals 261x. Plus our b is 5,036. Now that line is a predictor of our data. I can go back to my y equals and input that line and then graph it, and it will graph it right over my scatter plot, and you'll see how it's a best fit line. Okay? It goes through some points better than others. Okay, but clearly you can see that that linear regression was a pretty accurate one. All right? In exercise 3, go ahead and enter your data. Well, actually, let's do it this way. Let me do it this way. I want this crew to do exercise 3. Set up your scatter plot, take a look at it, make a decision on the regression. I want you guys to do exercise 1 at the bottom there. You got that? And I want you guys to do exercise 4 on that. Okay? And I'll do exercise, I'll do number 11. So we'll have 4 to look at. If you have any questions, just bring it up to me. I'm doing exercise 11. Raise your hand if you're done with your example. All right. Can I steal yours? How do you know? Steal Jacob's? I need your calculator. I want your calculator with all the data in there. And then, Chance, can I have your calculator? Oh, very nice. All right. And anybody from that FAR group over there have a calculator to share? We run into trouble? Yes, Scott, bring it to me. Let's see. All right, so I'm going to show you exercise 3. This was the temperature of a chemical reaction changing. Got them all lined up here. Okay. Here is Jacob's points plugged in. And what kind of regression did you run? Or maybe I'll let someone else answer this that's not in group 1. Like Jacob Phillips, what kind of regression would you think that is? Looks like a sine regression. Very good. I think so. Okay. So is that what you ran? Did you run a sine regression, Jacob Fender? Good. So he went to stat, he went to calculate, he went all the way down to sine regression, and he got, you don't have to worry about iteration, he got L1, L2, and they give you the format at the top. So his A, which is his amplitude, was 3.9. His B, which is going to be helpful to calculate his period, is 0.39. This C is negative 0.7, and his D is 38.5. So if he just plugs that into his Y equals, with those numbers all plugged in, that's how he got that line to go over the scatter plot, that curve. Excellent job. Okay? In the next example, Anthony, can you hand that to Jacob, please? We have, whose is this? Chance? Was yours linear? Okay. So Chance's is tough to see, but you can kind of see the green dots. And he thought that was linear. He ran a linear regression, and you know, we would just pull just like we did for the first one, we would pull the slope and we would pull the y-intercept. Okay? On the back side, send that back to Chance, please. Here is, now, Scott, I just hit graph for you, and I don't see a thing. When I hit graph, there's no scatter plot there. Okay, so you should change his, you should do that before you run the regression, because you got to see the pattern to see what it is. I know it told you maybe, it gave you some insight, and we've been familiar with these, but his X should go from 0 to, let's just go 365, so it's a full year. So 0 to 365. And his Y, the lowest number of hours of daylight, is 9. The highest is 15.2. So let's go from 8 to 16. And that's it. But that's it for 1 year. On its own, that looks quadratic, doesn't it? But understanding the cycle in the context of the problem, and did they also tell you that it should be sine or cosine or no? Yeah, they kind of did here at the end. Okay? Then you run that regression, stat, calc, look up your sine, and then copy down all those numbers accordingly. Okay? So it should be y equals 3.7 sine of 0.01 x plus negative 0.8 plus your d of 11.5. Okay? And on the last one that I did, taking a look at the speed of a car and the fuel economy. So my graph looks like that. To me, I thought that was quadratic. Okay? So there's a little hiccup here, but stat, calc, quadratic regression, all is good. Hit calculate, and you see how it gives me the format at the top and what numbers to plug in for A, B, and C. Now, I don't want to plug in 0, so I at least need to go out negative 0.008. Why does a negative A make sense? Because the parabola is opening down, right? And then my B value would be plus 0.75x, and my C value is 13.4. Okay?